Welcome again at IglooConf. It's my second IglooConf. I hope it's also your second IglooConf because it's a nice little conference here in Finland. I'm Maarten Balliauw and I will be talking to you about approaches for application request throttling. That's a very long title, but I could have made this title even longer because the goal of this talk is to give you an idea of why you would need something like application request throttling in any application. How you can do it from the technical side, but that's not really super important because that's something that we can solve as people who are in the IT industry, but more about the things that you have to consider when you are implementing rate limiting or application request throttling in your application that you are building. So with that, let's get started. Let's first look a little bit at users and traffic patterns. Users are awesome, but also users are not awesome, and I'll explain you why. So in my evening hours, I run a software as a service called MyGet, where you can host NuGet, NPM, Bower, VSIX packages, and so on. And that thing is a web-based application where you can manage your feeds, upload packages, do things like that. It's a typical management type of application. But there's also a big API that we host, because all of these package managers make use of some sort of an HTTP API to publish packages, to download packages, to get metadata for packages, and so on. And we added a little bit of our own APIs there as well, so you can delete packages and things like that. So it's two applications basically hosted by the exact same service out there. We were smart, and when we started building this thing, we made everything a little bit asynchronous, which means that something happens in the front end, you basically publish an event or a command to a queue, and that queue gets processed by background workers. So imagine you are adding a package to your feed on MyGet. What will happen is a message or an event is posted on an event bus, and we have a farm of worker roles that do a lot of things with that event. So for example, we process symbols for NuGet packages, we update the search index, we update a flag that says this is the latest version of a package, and so on. So one event can trigger many handlers in the backend to make this work. The nice thing is we can have lots and lots of requests on the front end, and there will be messages in the queue, but the front end will not die because it has to do all these things itself. There's a background worker doing these things asynchronously and making all that work. Now, what could happen if, for example, a lot of people start uploading packages to MyGet? Well, on the front end, of course, our IIS server will suffer. Because if you're uploading something, if you're pushing metadata into the application, you're actually using worker threads and so on in IIS. So IIS will suffer, but nothing that cannot be solved by scaling out and adding more front-end servers. In the backend, nothing can happen either. The only thing that will happen is that the queue gets fuller and fuller, and that processing may take a while to continue, but nothing will break down. But still, it's not nice because indexing may take a couple of minutes instead of a couple of seconds if that queue fills up. Too many downloads are also one of the nice things that we sometimes experience. Package managers are notoriously bad at using HTTP. The reason for that is most package managers just blindly fetch from all the upstream sources to get the packages in your solution. So for example, if you're using NuGet and you're using MyGet to host two packages, what will happen is that we get a copy of all the requests that you are also sending to NuGet, resulting in a lot of 404s in our application. Again, nothing to really worry about, but the thing is we have to run business logic on all those 404s because we have to check, can you access this feed? Do you still have an active subscription? All those things we have to check. And even if we do not serve you any content because the content is not there, we still have to run that business logic. So lots of downloads could be problematic for us theoretically because they consume resources on the server, right? Some other examples. I actually have a very, very recent real-life example. You may also want to limit the number of requests that are coming in on things like forms that you have on your web application. So for example, if you go to MyGet and you order or you want to order an enterprise account, what we had was a simple HTML form that would post an email to us. Now, as you can see, by the way, Outlook doesn't like this number of emails in a specific folder, I can tell you that. But what happened was that someone downloaded some vulnerability scanner somewhere and decided to target our website with it. No problem, we can handle this, except this mail form, because we did not have any rate limiting. They were trying all sorts of SQL injection stuff in that mail form, and we received a lot of mails, which was not very nice. So you want to limit the number of requests that come in on any resource that you have in your application, including forms like this. Imagine you're a credit card processor of some kind. You probably also want to rate limit the endpoint where you validate credit card details, because you don't want anyone to just brute force the form and check if they can figure out a valid credit card number, things like that. So we established in MyGet that we needed rate limiting, and probably your application needs it too. I may use rate limiting, I may use throttling. Those two are typically used in the same context. Right, rate limiting is typically limiting the number of incoming requests in a given time frame. That means whenever there's a bunch of requests coming in, you start limiting and saying, okay, you can only do 100 requests per second, for example. A lot of applications do this based on the number of requests, but maybe your ISP, I don't know in Finland, but at least in Belgium, it used to be the case that your ISP would also throttle your bandwidth that you could use during the month. So you can also do bandwidth throttling, for example. Limit the amount of data that someone can push over the network. By doing this, by limiting any of these resources, you're helping eliminate unwanted traffic patterns that could potentially damage your application. It's not known that they will damage your application. You're not withstanding a DDoS by doing rate limiting, but you are avoiding potentially harmful traffic patterns to your application. So you need rate limiting in your application. I have a saying where I say rate limit everything. So who of you is rate limiting their applications? Okay, a couple of people. I hope you guys are doing this. That's a good thing. Rate limit everything. So if you go home tonight, start rate limiting your application, because it's an important thing. Why everything? Well, because you want to rate limit everything that could slow down or break your application. And typically that means everything that you depend on and that is scarce in terms of resources, which means your CPU is a scarce resource. It's not infinite. There's a finite amount of CPU cycles that you can use. Same thing with memory, same thing with disk I/O, same thing with your database, same thing with making external API calls and so on. Anything typically that you are building in an application is somewhat limited in some kind, so you probably also want to put a limit on your external users to make sure they cannot abuse anything and make sure, and for example, make sure that your CPU can no longer process things. So rate limit everything. Let's rate limit something in an application. As developers, we are notoriously good at figuring out the technical side immediately when we have to start doing something. So if you go home and you decide, yes, I want to start rate limiting my application, what you may end up with is building a database where you add a couple of columns into a table named events, for example. You would add, for example, a user identifier. Who am I enforcing this limit on? An action identifier, what is the user trying to do, and when did this action occur? By having these three metrics, we can figure out how many requests someone is making in a given time frame, for example, and start rate limiting. The nice thing is we can write an MVC filter application, filter attribute, for example, run a couple of queries and figure out if we should impose a rate limit on that user or not. So by writing these three queries, you can implement rate limiting in your application. So let's do this in an application. And I actually did that up front. So what I did is create an ASP.NET Core web API in which I have a nice model. And my model is an entity framework database context where I store events that have a user identifier, an action identifier, and when did the event happen. Next thing I did was write a rate limit attribute that I can apply to my controller actions. So I have an hello API where I can rate limit anything. So I added my rate limit filter on that thing. And in my filter, what I'm doing is a couple of things. First of all, I'm trying to determine the identifier of my user. Who is accessing my application? Well, what I try to do is figure out the identity name as an identifier for the user. If the user isn't logged in, I just use the word anonymous as the identifier. This is very naive. This will probably break down because if you say, okay, anonymous users can only only use 1 request per second, every anonymous user will contribute to that limit, so this is not a good way of doing things. But still, theoretically, I have an identifier for my user and my operation as well. My action descriptor, I use the ASP.NET MVC action descriptor for that so that I know this guy is hitting this specific API endpoint and so on. Then I'm taking a reference time. I'm adding -5 seconds to it to sort of calculate the window of 5 seconds. And I want to impose a limit of only 5 requests per 5 seconds. I do that if the number of events in my database is larger than 5 in that window. I return status code 429, too many requests. And of course, I add my events to my database as well. So let's run this thing, and you will see that I have a perfectly working solution for rate limiting in here. Let's run it. We should have an API, and I think the API is called hello, and I can pass in a name as well. So if I say hello, Maarten, I should get back some JSON saying that I'm Maarten. There we are. Okay. So right now my number of events is 0 because it's the first request I'm making to my application. Now, if I run a couple of requests to my application, more than 5 per second, and I can do that by just F5ing a lot and skipping any debugger issues that I may have. Oh, come on. There we go. But you should get back a 429 at some point. Yes. HTTP error 429. And let's start zoom it as well. So you can see that I'm being rate limited in here. So that's it, technical solution to the problem of rate limiting. This is what you have to build in your application tonight, minus the exceptions that I had, of course. So awesome. There's nothing more to it. Just add a database, add some events, and so on. The problem is with that the database is a bad idea for this thing. The nice thing is I have this stream of events that I'm logging in my database where I can easily add windows, say I want to change this limit from 5 requests per 5 seconds to 5 requests per 10 seconds. I can easily do that by just changing the code because the database already has the data. The problem is that the database is going to be my next bottleneck. It is a scarce resource and I have to rate limit my scarce resources, right? That's what I said earlier in this talk. So the database will actually suffer at scale. If you have lots of requests coming in, every request that has to go through my rate limiting filter is at least 2 queries, potentially 3 queries. Why? I have to insert an event, I have to run a count on the number of events that I have, and I probably also want to do some cleanup because I may not be interested in events from last week, so I have to do a delete as well periodically. That means running inserts and deletes, my indexes will probably be under constant churn because I'm inserting all the time and maybe deleting all the time. The database will just grow. I think the page files of your database will also just grow, and probably your database server is eventually going to crash and burn. And it's not the way of doing things because you're probably introducing a new resource that will crash and burn your application, even though you wanted to prevent it from crashing and burning because of rate limiting. There's a simpler way of limiting the number of requests. Ideally, you do not want to run queries, you do not want to do any complex database logic. All you typically want is a counter. What's the number of requests for this user or for this type of request? That's all you want to have. So you have to think about how can we add a simple counter that is thread safe, that just works and doesn't impose other resource constraints in my application. Well, turns out that the industry has found a way of doing that in terms of buckets. If you search for bucket algorithms, you will find a couple of algorithms that you can use for rate limiting. And the widely used one is Quantized Buckets. Basically, if you want to create a counter, all you could do is create a key value store, maybe a Redis, maybe a dictionary in your application. I don't know how you will build it, but a simple key value dictionary where you have an identifier for the request and the user, your name of the buckets, and your counter. By using quantized buckets, there's a simple algorithm where you can sort of round the current time down to, for example, 10 minutes. And if you use this algorithm that I have there, what you will get is the same identifier for the bucket during a period of 10 minutes. So the nice thing is I can just generate this identifier, find the key in my dictionary or on Redis, and increment my counter. If there's more than X value in that counter, I can rate limit. So it's a really easy way of doing things. And in 15 minutes from now, that identifier will be different and I can start a new counter in my dictionary or in my Redis instance, which is kind of nice. There is one downside to quantized buckets, however. The nice thing is it's super easy to implement. It's only one simple counter and of course the key of what you want to store. But the problem is it's not precise enough. So imagine you have these buckets and we have a new bucket name every 10 seconds. You would get bucket A, bucket A01, A02 and so on within 10-second intervals. If there's requests coming in and I have my first bucket and I say I want to limit this to 4 requests per 10 seconds, this works. That bucket will have 4 requests. Second bucket will also have just 3 requests in it. The third bucket will just have 2 requests in it. The problem is if you want to really limit to 4 requests per 10 seconds as a statement, you're actually allowing more than 4 requests per 10 seconds because the bucket name changes every 10 seconds, but that means there's a gap where you can exceed your rate limit, right? May matter for your application, may not matter for your application, but it's an important thing to think about because maybe you're allowing more traffic than you actually wanted in your application. Another algorithm that's used in telecom, for example, is the leaky buckets. That's more precise, but you need more data stored. For the leaky bucket, you can compare it with basically a bucket where you have some holes in it. You keep pouring in water or keep pouring in requests. And as long as the bucket doesn't overflow, you're good. If it overflows, that's when you want to rate limit. So basically, what you want to define is a flow rate. How fast do my number of requests that I'm tracking flow out of my buckets, and how fast do the requests come into my buckets? The thing with that is that you have to track a couple of things. So a very simple, very naive implementation of a bucket algorithm could be I store the number of tokens that I still have or the number of capacity that I still have in my buckets. I store my capacity of my buckets, and I store when it was last replenished or when it was last flown out. Whenever my tokens are empty, I have no tokens left, that is when I would calculate if I should be rate limiting or not. So basically what we do is calculate a reference time from when we last replenished the number of tokens and just replenish the amount of tokens that we should replenish. If none, then we rate limit. If there's a number of tokens, then we are okay to go. Very simple algorithm, but I hope you don't have to write these things yourself. Another nice thing is that you can abuse Redis for this type of algorithm. So the leaky buckets, you can use Redis to sort of circumvent building your own algorithm. Redis has a concept of sorted sets. So I built a very similar application to what I had earlier, and I can do API requests and I can do rate limiting and so on in there as well. What I'm doing in here, instead of storing things in a database, is just let's go here first. Adding items to a sorted set in Redis. So again, I have an identifier, which is my current user or anonymous or a certain IP address and so on. And whenever a request comes in, I just add to a sorted set the number of ticks on my CPU right now. That's all I add, a simple counter. The nice thing is that sorted sets are sorted sets. So they are sorted, which means that we can simply check the right-hand side of our set and see if there's more elements in this set than I want to allow, then I rate limit. And that's what we are doing here. I'm getting a range of items in my sorted sets. If the number of elements is larger than 5, then I rate limit, because it's a list of timestamps basically that I'm keeping track of. And at the start of my request, I typically just remove the number of items that I no longer need. So everything beyond 5 seconds ago, for example. And by doing this, we are using Redis. We are typically storing just timestamps in memory. We'll be really fast. And we didn't have to implement our own algorithm. We can just use or abuse the sorted set in Redis. Right, so that's a couple of options on how you can build your own rate limiting algorithm and so on. Right, that's it, I think. No? We saw a technical solution. We saw a little bit on why we need application requests, throttling. We're done, right? Well, turns out we are not. we have to decide on the limits that we want to impose and a couple of other things. And that's going to be a large chunk of the remainder of this talk. We have to decide which resources are we going to limit. You cannot just add rate limiting to your application and just start rate limiting randomly. You cannot do this. So you have to decide which resources you want to limit, what the limit is going to be, come up with who are you going to limit? Is it going to be user-based? Is it going to be IP address-based? Is it going to be something else? And you have to decide on exceptions to the rule. You don't want to rate limiting your monitoring system, for example, right? So, which resources to limit? Anyone? Come on, you guys should know this. I already told you, rate limit everything. So that's an easy one to get out of the way, right? Rate limit everything because you're using CPU anyway, you're using memory anyway, you're using a database, you're using scarce resources, rate limit everything. If there's any takeaway from this talk, this is the takeaway.
Is the same speak for API management?
Yes.
Okay.
Yeah. Good. So rate limit everything. Then which limits do we impose on our application that we are building? Well, there's one approach. Well, there's a couple of approaches to start this. One approach that we considered but didn't really apply was just figuring out the current number of requests on average on every weekday. Just impose the limit and see whether support tickets come in. That's a way of introducing rate limiting, but I don't think it's the best way of introducing rate limiting. A better approach is do it from the start, or if you have an existing application, figure out the current number of requests, implement your rate limiting solution and so on, but do not enforce the limits yet. Instead of enforcing the limits, you simply log to application insights or whatever service that you are using the fact that someone is being rate limited. Because that gives you a nice log of rate limit events. You can go through it and check if the rate limit actually makes sense for that specific resource. That's one way of doing it. Refine those logs, refine your limits that you are imposing, and when you're comfortable with them, put it live and actually start rate limiting and hope no support tickets come in. That's a better way.
We should measure things on our...
Yes, measure things on your application. That's very, very important. I know.
Think before production, that doesn't sound. There are more steps in approach 2.
Approach 1 is better because, like any good developer, I do not test things on a test environment. I test things in production. Anyway, let's continue. Another thing to decide, if you have those limits, is will you allow bursting or not? Maybe you're good with just 10 requests per second. Maybe you want to allow 100 requests per second, but only during the first minute and then slow it down to 10 per second. So you may want to introduce something called laddering. Maybe you want 5,000 requests per hour, but allow more in the first minutes than you allow during the remainder of that hour. Why? Because maybe your API just has this usage scenario where you want to allow for more requests coming in and so on. So in this table, you can see that we are enforcing pretty much the same limits per second, but you can change it based on when the user is coming and how the flow keeps coming into your application. Right. What will be the identifier? We already saw in my stupid example that filtering based on the user called anonymous is probably not the best way of doing things. So we need something better. Maybe an IP address, but still there's a lot of people behind proxies and nets and firewalls, and maybe IP is not the best measure to use, but it could be a good one. Maybe per user, but then again, if that user has a farm of 25,000 build machines all hitting your service, maybe you don't want those 25,000 build machines all coming in with 10 requests per second. So maybe user identifier is not the best idea either. Maybe you want to track per session, so that you can rate limit every one of those 25,000 build agents hitting your service, right? But what do you do with anonymous users? What do you do if there's an API where you cannot enforce sessions? So you have to think about that as well. Maybe you want to limit per browser, per session, per user, per IP address. So you have a combination of all these factors, and you can be more detailed about who is really using your application and who are we going to limit in that application. And that's probably the best way of doing things. Combine some of these identifiers and try to be as accurate as possible in identifying who your user is, because that's the only way of accurately enforcing a limit to the number of requests that they can make to your application. Then, of course, you also have to decide on exceptions. You established a rate limit. You established who are we going to limit. Now it's time to establish who are we not going to limit. A good candidate of that would be do not limit your monitoring, unless your monitoring has to monitor the rate limiting fact. But probably you do not want to have false alerts at 3 a.m. coming from Pingdom or whatever service you are using because you're being rate limited while you are monitoring and the application is just fine and dandy. What about web crawlers? You probably have some marketing guys in the company as well who do not want to see a rate limit on just the home page or the pricing page, but still, you should probably limit that page as well, because there can be things that go wrong if it's not a static page. But maybe if Google comes along and they crawl your website, you don't want to rate limit Google because you want to end up in search engines, right? There's a couple of data center ranges out there that are typically not used by end users. So if you're building a customer-facing application for just regular human beings, you may want to impose a limit on certain data center ranges so nobody can use their own crawler to try and analyze your website for something, or maybe you do want to allow this. So think about the exceptions to the rule. Think about what you are going to allow even though you have rate limiting for other users. And maybe if you think about a business model around rate limiting, maybe you could sell exceptions, right? You pay me 100 euros per day, you get more requests per second. That's also a nice way of doing things. How do you respond to limits? We established that we want to rate limit. We established who we are going to limit. How do we respond to limits? What happens when you are limiting someone? Do you just black hole and close the connection? That's one way of doing things, but I'm not in favor of that. Typically, you want to tell the user that they are being throttled, using status code 429, for example. And maybe you also want to give them some information about why you are rate limiting them. So, for example, this is a nice example that I always have when I answer a Stack Overflow question. I'm always logged out on Stack Overflow. I see a question, I start typing my answer, I click submit, and then I have to log in. Then I just click login because my password manager enters the username and passwords. And because I'm too fast for Stack Overflow, they always rate limit me with this nice CAPTCHA where I have to prove that I'm not a bot. This is rate limiting in action, but they made it a nice way of showing me that I'm being too quick for a normal human being. They give me a nice example of why I'm being rate limited. They tell me that I'm being rate limited and that I have to do something about it. If you're building just an API, you probably want to do something like GitHub does. They have a nice way of telling you what your current limit is and how many requests you still have left and when the limit will be reset. So this is a really nice way of doing things. If you have an API, tell the user with a 429 status codes and just tell them what the limits are, maybe even add the link to your documentation with additional information on what the limits are, how you can upgrade those limits, and so on. So tell the user why, because otherwise they will ask you through support forms, and you don't want that. Right, where do we limit? We already added some limits inside our application where we could access our MVC controller name, our MVC action name, and so on. But maybe there's better places on where to add rate limiting in our application stack. If you are a typical developer like I am, you typically go to NuGet, you search for throttling or limiting or whatever, and you end up with many, many NuGet packages. A couple of nice ones are MVC throttle, which is an action filter that you can add to your MVC application or Web API application, and they will run the filtering when an action executes and when an action finishes. That's really in the application inside the MVC framework that you are doing the limiting. Maybe you want to take one step back, and instead of rate limiting when you're already in the ASP.NET MVC stack, maybe you want to rate limit right before that. Maybe you want to add Owin.limits and just add an Owin middleware, so that if you want to enforce rate limits, you don't even go into your application. It just stops when the middleware executes first. That's also a good approach. There's many others, and you can just add them to your application and see which one works for you. So if you look at MVC Throttle, for example, I'll do a very quick demo of that. You will find that on every controller in your application, you will be able to either disable throttling by just saying disable throttling, or enable throttling and you add the limits there. Per second 2, per minute 5, and so on. Very simple to configure. And as you know, ASP.NET MVC and Web API, you can apply this as a global filter as well, so you don't even have to decorate all of your actions with it. And even if you add it as a global filter, you can still do more fine-grained throttling at the action level methods. So you can combine those two approaches. Nice thing is, if you do it at the global level, you can do a couple of interesting things. So for example, in this application, I added my MVC throttle filter as a global action filter to my application, and I'm doing a couple of things. I'm scoping 2 IPs, so I'm using the IP address as a source for throttling. I'm also using my current client, my currently logged in username as an identifier for throttling. I'm also using endpoint throttling, which means that I take the full URL to determine the identifier for the data point that I'm trying to capture. I'm using user agent throttling here as well, so I'm building a really long identifier to be really specific about who am I rate limiting here. Nice thing is that because I have more options using this global action filter approach, is that I can also add exceptions, for example. I do not want to enforce throttling when I'm just developing my application on my local machine or on my local home network. I don't want to throttle the Googlebot IP address ranges. I do not want to throttle Bing. I do not want to throttle Yahoo or Yandex or whatever search engine may hit my application. Maybe I also want to whitelist logged in users. If you're anonymous, we throttle you. If you're logged in, you're fine and we do not limit you. That's also one that you could do. You could add additional endpoint rules. So for example, if you have a pricing page, even if it's a static page, if it's served up through the ASP.NET MVC middleware, then you can limit, for example, a specific URL in your application and set it to a certain number of requests per second. Now, the cool thing is, if I run this application, we will be able to see throttling in action. So if I go to my About page, for example, when it loads and if it loads, or to my home page, I can just reload a couple of times, and after a while you will see I'm being rate limited just by adding this MVC throttle NuGet package and adding this attribute to my ASP.NET controller. Nice thing is, I told you should probably mention the user that he's being throttled and why. Well, MVC throttle does this for us. It has a maximum admitted 2 per second, which it sort of generates based on the limits that you impose in this attribute. So it generates this message for you. Another nice thing is that if we create an override of our MVC throttle default filter, we can also override what we show the user. And what I'm doing here is basically checking the accept types of my requests. If the accept type is anything that contains HTML, so if it's a browser, I render a view. If it's not a browser, I simply respond with a 429 and some JSON. So that's also a distinguishing thing that I can do in here. Right, any questions so far? Just giving you a couple of simple examples here and we'll go deeper right now. Good, I already told you that you can limit as a middleware. You can do it in your MVC stack. You can even build your own thing as a function call in every method that you have in your ASP.NET application. You can go really deep in your application before you actually hit the brakes and throttle the users that are coming in. Question is, how far will you allow users to come into your application before you say no or you are being rate limited? Do you stop them at the data center level when they just come into your network? Is that where you stop the throttle the user? Do you stop them when they hit your server? Do you stop them when they hit the process in which your application runs? Or do you stop them when they actually hit your application itself? All of these locations have pros and cons, basically. If we flip the labels on this thing, we can look at it like this. If you filter inside of your application, you will have lots of knowledge about what the user is trying to achieve. You will have a context of who is this user, if they are authenticated. You will know which action method they are executing. You will know everything because it's in your application and you have all the data at your disposal to decide whether you want to throttle or not. The problem is, the deeper you go into your application, the more resources are spent. And I told you rate limit everything that consumes scarce resources. Well, your application is a scarce resource, so maybe you want to limit before that. Problem is, if you limit before that, you are going to middleware or maybe at the firewall level, you do not have as much information about your user as you may want to impose a limit. So it's a little bit of a trade-off between how many resources do you want to spend on handling this potentially throttled requests versus how much information do you need from your user before you throttle them. Maybe you never need to know the currently logged in user. Maybe you don't. Then use the firewall, for example, for rate limiting, because you do not want the user to end up in your application in that case. What options are there? Well, we looked at filtering inside of your application using an application filter or a middleware. That's a perfectly valid approach. And you have an easy way of adding custom logic because it's inside of your application. It's an easy way of doing things and probably the best place to start with if you have an existing application because you have full control, you do not have to fiddle with environment setup and so on. Another option is filtering on the server. IIS has a couple of modules that allow you to do request throttling. However, I find them stupid. Why are they stupid? Because they violate a lot of the things that I talked to you about during the talk so far. Because if you enable, for example, dynamic IP restrictions in IIS, they will just filter based on the IP addresses coming in. If there's more than 10 requests from a certain IP address, they will block you. They will not block you with a custom status page. They will not block you with a nice error page. They will just block you with a 403 forbidden. Which is stupid because that will typically trigger authentication, then get back to your application and you end up with all sorts of problems that you do not want to have because forbidden doesn't mean that you are being throttled. Forbidden means try to re-authenticate and improve or extend your currently authenticated user. So that's not a good way of doing things. Another problem with IIS-based throttling is that it's already part of your application. If you're running in the integrated pipeline modes, these modules are just .NET-based things that run in the same pipeline as your application, and you're already in the application. So if you're doing any of these, you may want to do it in the application anyway, because then you have more control of what the output will be to the end user. We can throttle outside of our server. We can implement a reverse proxy and add throttling in that reverse proxy. And that's actually a really, really easy thing to do. You can use Nginx, IIS application request routing, HA proxy, Squid, whatever reverse proxy you want to use, you probably can do rate limiting in that one. I like Nginx for that because it's really easy to do. So what I have on my application here is a nice Docker container. And in that Docker container, I will show you the script that I have to start my Docker container. My Docker container is called the machine, because the machine is like the machine. And I'm using the Nginx latest Docker image. That's all that I do. The other thing that I do is configure Nginx. So let me first show you what the result looks like. I have my application running here in Nginx, and this is just public mygets, but I'm proxying it through, as you can see, my local host, which is the Nginx that I have running on my Docker container. Nice thing is, I have proxying of my entire application, and I can even hit a certain API and look at packages, for example, and I can refresh a couple of times, and at some point, we should see rate limiting in action. I'm not fast enough, or the network is not fast enough, but probably me. Let's try a couple more times. Yes, there we are. 429, too many requests from Nginx. So I'm just proxying our currently live application through Nginx, and I'm enforcing rate limiting in Nginx. Now, how do you do this? Because Nginx, it's this Linux thingy. Who is using Nginx, by the way? Okay, a couple of people, good. Nginx is really easy to set up. They have a nice DSL to configure what your application server will look like. There's a bit of boilerplate things that you have to add, like the number of threads and processes that you want to run. But at some point you say, I have a server listening on port 80. For the location / everything that is under the root of my application, what I do is simply set 2 additional headers on my requests, pass off the request to my upstream application, and that's it. So whatever resource you hit under the root of my application, we are just proxying it in Nginx. Nice thing is, because I'm using Nginx, I can do proxying, but I can also do proxying and caching. So for example, for my images under /content, what I do is proxy them, same thing. But what I also do is cache them for 10 minutes. So all my CSS, all my images and so on underneath of this directory are being cached in Nginx as well. Nice additional benefits. But we are here for application request throttling. So what I do is everything that is a feed on my Git under /f will be limited using the myLimit zone. I will return a 429 status code, which we saw in the browser, and just proxy it to the upstream web application. Now, what is this myLimit? Well, that's the only thing that we have to add if we want to enforce request throttling in Nginx. MyLimit is defined here, where I say, okay, I have a limit called myLimit. It's valid for 10 minutes. It's a sliding window or a leaky bucket, if you look at the algorithms. And I want to allow 2 requests per second in this myLimit. Nice thing is, I can also override a couple of properties there per directory that I have on my server. So I can say, okay, I want to allow bursts of up to 5 requests per second for a couple of times. So additional benefit that we have there. By simply adding this, we have 429 too many requests on our application. Really simple to add. We also talked about identifiers, and in Nginx, you will see a lot of examples on the internet where this is defined, and you are limiting based on the binary remote address. That's just the IP of the client, and again, that's probably too limited to determine who is really accessing your application. So maybe you want to extend this identifier, which is the first parameter here, to something that also includes, for example, your HTTP authentication header, so that you have an idea of which user is actually hitting your application and you are rate limiting the proper user there. So that's, in a nutshell, how you would do it using Nginx. Now, Nginx is nice, but it's also a bit annoying because you have to know how Nginx works. You have to read into the documentation, try a couple of things and so on. You have to stand up your own environment of Nginx edge servers that sit in front of your application, which means you have to manage them, which means you have to monitor them, which means you have to have a guy who will wake up at Saturday morning or Sunday morning, 2 a.m. if the Docker host decides to upgrade and the Docker container doesn't come up and those things. So you have to maintain your thing, right? Still, it still runs in your data center. So if you are paying for traffic to your data center, you're still paying, for example, for the traffic that is coming in. So maybe limiting at the edge of your application or your data center is not yet good enough. Maybe you want to limit outside of the data center. Outside of the data center, there's a couple of options. You can use CloudFlare, for example, or you can use API management. The nice thing about those is that a lot of them, I know CloudFlare is, for example, also implement a CDN. So they have different edge locations around the globe where they run your configuration. So you get the benefit of CDN plus rate limiting plus proxying plus DDoS benefits and so on. So outside of the data center may make a lot of sense to do. And I will show you quickly how to do it using API management. I have my same configuration running here, but this time it's not running in my local Docker container. It's running on iglooconf.azureapi.net. I can, of course, add a custom domain name as well. But if I hit this site, I will simply get my application, can go to the features and so on. But the nice thing is, if I go to a specific feed on that, I should use shorter names there. If I go to a specific feed, I still can access my API over the API management gateway. But if I have too many requests, you will see that I get back a 429 with rate limit has exceeded. Try again in 4 seconds. Exactly what I want, because I get a nice message saying that I'm rate limited. I get information about when I can try again. and I didn't have to do a lot for this. I only had to configure API management. So what does this look like in API management? You may, if you have ever tried this in the Azure portal, you will have a nice portal with lots of useless things, because the most useful stuff is in the publisher portal, where you can really manage your API management gateway. And that's this dashboard. You get a nice overview of all the APIs that you define in there, and you can configure each API with its own terms. So for example, in my API management gateway here, I defined 2 APIs. One API is... I have to log in again. Then the question is this going... I'll just open it from the portal again, because I don't know if that's live ID or not. Let's try again. Okay, I have APIs, and I defined 2 APIs in my application. I defined typical mygets, which will be just the root of my application, and I defined feeds, because that's the interesting thing that I really want to rate limit in this application. My regular mygets API simply has a couple of settings where I say it's the website, it runs there, you can proxy it, add HTTPS to it, done. That's all that is added in there. The interesting one is the other one that I have, the feeds. Every endpoint that looks like /f, my web API URL suffix, has to be proxied to /f on myget, because that's where my feeds live, right? Nice thing is that for this specific API, I can define things like operations. I can allow gets here, but not allow post, for example. This is stupid because my API actually has to work with post as well, but I didn't add it in here yet. But you can define limits per operation. I want to allow 1 push per second, but I want to allow 50,000 downloads per second, for example. That's what you can do here. I can apply security to a certain API. So I can say, okay, for this API, add some basic HTTP authentication in front, or add Azure AD, or add whatever in front of this API, even though my application may be completely unaware of the fact that I add authorization in my API gateway. Now, for every API, I also have to define policies. And I have a policy for my product Anonymous, very good name for a product, and my API called feeds. I have a policy that you can define in a nice XML editor. This policy defines that I have a rate limit by key. The key is based on the current path of my requests. I increment with 1 whenever a request comes in. I allow 1 renewal every 5 seconds, so I want to reset the counter every 5 seconds. And I only want to allow 5 calls here. That's pretty much everything there's to it. I have to define a policy on how many requests can come in here, apply it, and my API management gateway does this stuff for me, which is kind of nice. Add to that I can add HTTP authentication, for example, or AD authentication. Add to that in here I can also define different products for my APIs. Makes API Gateway a really interesting one to use in your application as well. What do I mean with different products? Well, remember when I told you you could make a business model out of your API where you say, if you pay me money, you get a higher limit? You can do this with API management. Create a new product, not called Anonymous, but Super Duper User or something like that. Add additional limits in this policy file, and then when a user is identified to be a Super Duper user, they will have different limits on the API management gateway. So really nice to use there. With that, I have 1 minute left, and that's just enough for the conclusion. Everyone, what do you rate limits? Everything. Thank you. That's the main takeaway of this talk. Users are crazy, but unintentionally. They will hit your application, they will hit your forms, they will run probes against your application, things like that. You always need to rate limit, and as you said yourself, rate limit everything. Decide on the resources you want to limit, decide on a sensible limit, use the logging approach and don't block immediately. Come up with a good identifier to be as specific as possible about who you are going to limit. Decide on exceptions. Don't limit your monitoring system, for example, or make people pay for better limits on your API. Decide on a nice way of telling the user that something is wrong and give them a link to the documentation and things like that. And decide on where you want to add limits. Maybe an API management gateway, maybe Nginx, maybe inside of your application. It depends on how much information you need about your user before you actually say stop. That's the thing. Thank you for being here, and rate limit everything.